All right, so that's 4-4. Now we're talking about conditional probability and independence. And again, because I teach geometry, I know that we discussed this in geometry. So again, this should be a refresher, hopefully for you. So note here, the probability of an event can change if we know that some other event has occurred. Right? So knowing something has occurred is going to affect the situation, right? It's not an open situation, then it's more closed. It's like, okay, um, I have somewhat of an idea what's happening. So now what's the probability? So this is where conditional probability comes into account, right? If some event has occurred, that's the condition. Oh, this has occurred. So now what's the probability of something else? So it's the probability that one event happens given that another event is known to have happened. We already know something has occurred. So the conditional probability that B happens given A, B happens given A, is this right here. P of B given A. This bar means the word given. So B is what we're trying to find the probability of, and A is the event that has happened. What I always say is that when you're looking at conditional probability, you are limiting the total. Limiting the total. And I'll put total underline, because when you are looking at a probability, typically it's what you want out of the total. But if you're looking at a conditional probability, you're given something. So no longer are you looking at the total, but you're just looking at it from the given, right? So in this case, instead of looking at the total, it'd be like looking at just A's. Whoever the A's are, whatever the A's are, now of those A's, how many are also B? That's what we're looking for. So it limits the total. So think about that. Limits the total. Okay, so example 1. Who rides snowmobiles in Yellowstone? Yellowstone National Park surveyed a random sample of 1526 winter visitors to the park. They asked each person whether he or she owned, rented, or had never used a snowmobile. Respondents were also asked whether or not they belonged to an environmental organization like the Sierra Club. Don't know what they are, but good for them. The two-way table summarizes the survey responses. So along the top here, environmental club, yes, I belong, no, I don't belong, and then snowmobile experience, never used, I'm a renter, or I own a snowmobile. And again, notice the total. Here's your 1526. Suppose we randomly select one of the survey respondents. Define E as environmental club. So yes, E, environmental club. Define S as snowmobile owner. So S is owner, and define N as never used. Okay, so this is for all of our problems. Find the probability of N given E and interpret this in context. So the probability of N given E. So what that means is I'm going to put my bottom number in first. And my bottom number is going to come from the given. Instead of looking at everybody, instead of looking at 1526, I'm not going to. I'm going to look at all of the E's. I am given that this person is an environmental club member. So the E's are here. I'm looking at all of the people in this column, which is a total of 305. Out of those 305, now I'm looking for who has never used a snowmobile. Who has never used a snowmobile? These 212. So this is how you do conditional probability using a two-way table. You first find the total number of people you're looking out of, and then from that total, you find who also is the first thing. Okay, so I'm going to divide those 212 divided by 305. And I got 3 decimals, 0.695. I'll do that in blue to make it show up. 0.695. And now we're going to interpret this in context. So when we interpret this in context, it's going to be very similar to before. So except we're going to put the given first, right? So given that a randomly chosen person, there's that word randomly, that a randomly chosen person is an environmental club member, is an environmental club member. And now we go back to the last section. There is about a 69.5% chance. There is about a 69.5% chance that he or she has never used a snowmobile. A snowmobile. I was going to say snowmobile. A snowmobile. And there we go. And that's the interpretation. Okay, so again, notice I start with that given. But again, there is about a 69.5% chance. All right. Cool. All right, good. Next example, part B. Okay, so same prompt, right? So let me go back to this table. So this is still E, this is still S, and this is still N. So now, given that the person is not a snowmobile owner, so not, this means complement. So snowmobile owner was S, so this means not a snowmobile owner, SC, as complement. What's the probability that he or she is an environmental club member, which is E? Write your answer as a probability statement using the symbols for the events. So we're trying to find the probability that somebody is an environmental club member given that they're not, or they have not owned a snowmobile. Okay. So now I need to look at all of those who have not used a snowmobile. This is the word given. We start down here first with the given, and down there is going to be all of these people. Well, these are the snowmobile owners, so just don't include them. Include everyone else, which is going to be these two boxes. So now I have to use both of these as my total. So my bottom is going to be two numbers, 657 plus 574, and that could happen. And now my top is going to be all those in those two rows that are environmental club members. Environmental club members, yes, these two, 212 and 77. Okay, so I'll simplify both individually. So 212 plus 77, that is a total of 289. And then the bottom is 657 plus 574. 574, sorry. 657 plus 574, and that's 1231. So again, notice I did not use the total in the bottom right corner again. You're not going to in these conditional probabilities. It limits the total. And 289 divided by 1231, that's 0.235. Cool. So again, hopefully this helps you understand how to find conditional probability from a two-way table. And again, I invite you to write the table down when you see the problems in Edge Elastic and draw all over your tables.